Hello and welcome to D Creations Resources. We are talking about concepts from mathematics and especially real analysis. We already talked about different classes of numbers and the geometrical interpretation in terms of the real number line. Now let's talk about intervals. So here you can see four kinds of intervals. Of course, the examples here shown are not the only ones. We will be discussing all kinds of intervals. So when you say there is a set, then there is also the concept of subset. That means only certain objects in that set. Of course, there is a rule governing that. So if you consider this whole real number line as a set, then you can see that an interval is kind of a subset. Now they can be of different types. Now there is open interval. Here you can see the first picture represents an open interval. So you can see that a round bracket is used and 2 points A and B, and they are in the round bracket. This means that all the numbers lying between A and B are part of this interval, but A and B are excluded. They are not part of this interval. So for example, if you consider 1, 5, the open interval, in round brackets you have 1, 5, then 1 is excluded, 5 is excluded. But then what is included? Of course, I have not written all the real numbers in between. Right now I have just shown you 2, 3, 4. Now, if you want to speak more about open intervals, you can say that the set of all real numbers that lie strictly between two fixed numbers A and B is called an open interval. So we use the term lie between two fixed numbers or lie strictly between two fixed numbers. That means the boundary or the numbers that we are talking about, when you say all the numbers lying between A and B, we understand that A and B themselves are excluded. So you can also write it as A less than X less than B. So all the X which are greater than A and less than B are going to be included here. Now this is called an open interval because neither of its end points are included in the interval. Now with this logic, can you define a closed interval? Very good. A closed interval is that interval which contains both its endpoints. So the second one, as you can see here, is representing a closed interval. So when I say 1, 5 in a closed interval, you can see that the bracket has become a square bracket. So a round bracket is reserved for open interval, a square bracket is reserved for a closed interval. And here whatever numbers are there, again here for simplicity I have not listed all the real numbers, I have just listed the integers lying between, or rather in the closed set 1, 5. So 1, 2, 3, 4, 5. The most important point to note here is that 1 and 5 is included, and all the real numbers lying between these intervals are also included. So a closed interval contains both of its endpoints. Now if you want to represent it by an inequality, you can say that A is less than or equal to X, less than or equal to B is the closed interval. Now there are also half open intervals which contain only one of their endpoints. So for example, if you see that if I write it as square bracket A, comma B, round bracket. So the endpoint which is near a square bracket is going to be included, or in other words we can say that A less than or equal to X less than B. So now if I ask you that if I want to write it say as in this manner, square bracket A, comma B, round bracket. So if I say assign a value of 1 for A and assign a value of 5 for B, then what is this set going to represent? It will be all the real numbers. Again, I am going to just list out integers 1, 2, 3, 4, because even though the value of B is 5, it's on the end near the round bracket, so that is excluded. So this is an example of an half interval. Now of course there would be a corresponding half interval where you can say that instead of this particular square bracket, you can have a round bracket here and a square bracket here. So when you have this as an interval, when you say that square bracket 1 comma 5 round bracket, that means 1, 2, 3, 4, and of course all the real numbers, they are going to be included. So interval, as you can see, is going to tell you about this whole portion of the line in between. Depending on whether it is open or closed, the only change is going to be whether the endpoints are included. So if it is an open interval, endpoints are excluded. If it is a closed interval, endpoints are included. So now of course this particular expression where we talked about the half interval square bracket a comma b round bracket, this can be written as a less than or equal to x less than b. Now we learnt about open interval, closed interval. This particular thing is called half open interval, and the other half open interval also we talked about. Now what about the intervals which are written with infinity? These, so far whatever intervals we talked about were all finite intervals. But then there are infinite intervals. You can see two examples here. A infinity lying between two round brackets. That means all the numbers which are greater than a are going to be part of this. Because this is a round bracket, a will not be included, but all the numbers greater than a will be included. What about the situations that minus infinity comma b square bracket? Now here you can see all the numbers which are less than b will be included, and b will be included itself because there is a square bracket. So you can see two examples down here. So 1 and infinity written in a round bracket, this is going to correspond to all the numbers greater than 1 as we had spoken. So 2, 3, so on and so forth, in fact all the real numbers. Similarly, minus infinity comma 2, that is written in this bracket. Here it is going to be all the numbers less than 2, and 2 is also included. So you can see the last entry is 2. And all the ones less than it, so 1, 0, minus 1, etc. and all other real numbers, they are all included here. So far what did we see? We looked at an open interval, a closed interval, half open intervals. There are two kinds. All these are finite intervals, and then we looked at infinite intervals. Again, there could be a round bracket or closed bracket, but you should note that when you are writing infinity, that bracket is always an open bracket. Because it's very clear, right? Infinity is not a number per se in that sense. So it has to be an open bracket. So this is all about intervals. Try to write down, construct your own intervals and try to write down what elements they are going to contain. Thank you.